The fourth quadrant trips a lot of people up. It does. Because we have this 270 here and we think it might be a little bit easier to go that this is your 30-degree angle. But it's always coming from your x-axis. Always. Okay? So we're using 180 to subtract our key angles. So 180 minus 30 gives you 150. 180 minus 45 gives you 135. 180 minus 60 gives you 120. Then on the flip side, for the third quadrant, it's 180 plus 30, 180 plus 45, okay? And then the fourth quadrant, like I mentioned before, it's 360 minus. So I only use, let's see if there's a different highlighter. I'm only using those two guys. I never use my 90 and 270. Okay? So again, that's, you guys just saw this once, completely filled out 2 days ago, right? So if you're still unsure, that's okay. That is 100% okay. But the more you do, the more practice you do, even if you were to print out your own unit circle, and you could just Google unit circle, blank one, if you were to print these out and it's all repetition. But the key, what I put on your sheets, the key quadrant to know is this first one. This first one helps you out, okay? A few other tricks. One, if everyone wants to hold up your left hand, hold up your left hand, okay? Your left hand is quadrant 1. 0, 30, 45, 60, 90, okay? If you notice, denominators all the same, so we know that. They're all 2, right? They're all divided by 2. Square root of 3, square root of 2. This would have been square root of 1, but what's the square root of 1? 1. Okay, so you have your left hand. If I drop down this, my 30-degree angle, how many are here? How many fingers? 3. How many are here? Square root of 3 over 2 and 1/2. Is that what I have for 30 degrees? Okay. Drop your middle finger. How many on either side? Square root of 2, square root of 2. Okay. Drop your ring finger. How many here? How many here? 1/2 square root of 3 over 2. Okay. So your X is on your left, your Y is on your right. Okay. Now, for your 0 and 90, okay, if I was to drop my thumb, right, I have 4 fingers. But remember, your numerators are already taking the square root. What's the square root of 4? What's 2 over 2? Is that what I have? Yeah. Okay. Now if I drop my pinky, which I need help because I can't do it by myself. Okay. If I drop, this is my 0. How many fingers do I have? What's the square root of 4? 2 over 2. So your left hand can be your first quadrant. Okay. Just noticing if you're having trouble, especially 30 and 60, by doing that, that would help. Okay. To just get you started on that first quadrant, then you could fill out the rest. Okay. You could also do a bow tie like we talked about last class. Okay, these angles. The circle is going to be the same. The blank circle will always be the same. There's going to be no surprises. There's not going to be extra lines, meaning extra angles drawn in. It's going to be the same. Okay, so when you're filling this out, there's no surprises. It's just for you to make those connections. Some of you might choose to always use color pencils or pen highlighters, whatever, to fill this out. Go ahead. That also registers that you're making those connections. Okay? Questions? All right. A few things that I want you to add to that blank sheet, okay? To the blank sheet right in front of you. I'm going to do it on a separate sheet. No room. But either way, you could use next to the unit circle if you wanted to. Okay, so we have our quadrant 1. Okay, in quadrant 1, in terms of x and y, what do we have? Are they both positive? One negative, one, what do we got? Both positive, right? So we use the word all, okay? Because in terms of sine, cosine, and tangent, all three of those these are positive. So I suggest you write this down. Okay? When we move to quadrant 2, what's the deal in terms of x and y? The x coordinate is negative. Okay? So we use the word students. Okay? Since the x is negative, okay, what is positive is sine. The sine is positive, but cosine and tangent are both negative. Okay? Then we move to quadrant 3. What's the story with quadrant 3? Hannah? Both are negative. Okay? Both are negative. We use the word take, so all students take. Here, tangent is positive. Sine and cosine are both negative. Okay, so the words tell you, the first letter of the words all students take, that first letter tells you what trig ratio is positive. Okay, and the last one, we have quadrant 4. What's the story with quadrant 4? Y is negative. Y is negative. Use the word. All students take classes. Okay, where cosine is positive, sine and tangent are both negative. Okay, so, and also keep in mind that your sine is your y values. Cosine is your x values. Okay, tangent is y over x. That's why this is positive. Because a negative over negative gives you a positive. Okay, so just to remember and recall, sine is your y, cosine is your x, which we're going to talk about a little bit today, and tangent is your y over x. Okay, which leads us to the next part of our notes. So if you could take out your note packet. Take out your note packet. So, in terms of SOHCAHTOA, okay, just to refresh, our sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, and tangent is opposite over adjacent. So when we get to the unit circle, okay, the side opposite from any central angle that represents the height, okay, opposite, okay, represents the height. What value would that be? X or Y? The Y, good. Okay. Then the side adjacent from any central angle that represents the width or the horizontal length is known as what value? X. Okay. The hypotenuse of the triangles in the unit circle now represent the radius. Okay. Now represent the radius, which is known as R. Okay. So with sine, instead of opposite over hypotenuse, how would I replace that with X, Y, and R? Yeah. Good. Y over R. What would cosine be then? Instead of adjacent over hypotenuse, how would I change that? Rory? Good. X over R. Then tangent, opposite over adjacent, what would that look like? Hannah? Good. Y over X. Good. Excellent. Okay. So now we're going to see the relationship between the two again. All right. In terms of sine, cosine, tangent. So we have our right triangle, and we're going to use SOHCAHTOA first. Okay. So SOHCAHTOA for cosine is adjacent over hypotenuse. So what would be the cosine of 30? Root 3 over 2, right? Okay. Root 3 over 2, and then over 1, which is just root 3 over 2. How about the sine of 30? Yes, Zach. Good. 1/2 over 1, which is just 1/2. Okay? Then if I look, the same triangle, but now we're looking at 60, okay? Again, cosine adjacent over hypotenuse for 60 degrees. What would that be? Nick? 1 over 2. What would the sine of 60 be? 3 over 2. Good. Basic in terms of SOHCAHTOA, right? So now we get to the unit circle and our lengths are gone. So we just have that 30-degree angle. So, but we do have a point on the circle, root 3 over 2 and 1/2. So what did we say above or on the previous page? Cosine are what values? X over R, right? Okay, remember my radius is 1. So cosine of 30 is what value? Root 3 over 2, because that is my X value. What is the sine of 30? Yeah. 1/2. Good. Because that's Y over R. Okay. Well, 60 degrees isn't mentioned here, or it's not labeled, but looking at your unit circles, for 60 degrees, what is my point? What is my coordinate point for 60 degrees? Hannah? 60. God bless you. Eve? 1/2 and root 3 over 2 is my 60 degrees. Okay? So therefore, what is my cosine of 60? 1/2. What is the sine of 60? Nick? It is root 3 over 2. Okay? So, looking at the comparisons, which is exactly what we found using SOHCAHTOA, we go from the SOHCAHTOA, or special rights, to now the unit circle by taking our side length and making it our coordinate point. Yes, Hannah? Correct. Yep. It would be just the XY. Okay? So, in terms of tangent, okay, this is where it gets a little tricky at first. Okay? It is y over x. Okay? So if I wanted to take the tangent of 30, okay, so 30 degrees, remember, is root 3 over 2 and 1/2. Okay? So if I had to set this up in terms of tangent of 30, what would that look like using my coordinate points? Yeah. Good. So to start, this is what it would look like. It's kind of ugly to see. 1/2 over root 3 over 2. Well, that's a nasty fraction, right? Okay. Well, one thing with this, anybody know what I could do here? Yeah. Okay, we could do that. Okay, we could do that. From here, if you see fractions within a fractions, Emily's right. You could multiply top and bottom by 2 over root 3. We could simply cancel out those 2's because we know they're going to cancel out. So we're left with 1 over root 3. Can I have a radical in the denominator? No. So how do I get rid of it? Yeah. Good. Multiply top and bottom by root 3. What do I end up getting? Rory? Good. Root 3 over 3. So the tangent of 30 is root 3 over 3. Okay. Now if I write my coordinate point for 60, it's 1/2 and root 3 over 2. Well, tangent is y over x, so what would this look like? What would this setup first look like? Zach? Good. So, square root of 3 over 2 over 1/2. Well, the same thing applies here. Both those 2's, what would happen? Cancel out. So I'm just left with root 3 over 1, which is just root 3. Okay. All right. So we're going to use our unit circle. Okay. And I give you some hints above. Cosine of theta equals x. Sine of theta equals y. Tangent is y over x. So, using your unit circle, and I'll put a complete one up here. I'm going to show you what this looks like at the beginning. Okay? We'll do the first 3, A, B, and C. Okay? Because they're all 45 degrees. What is the sine of 45 degrees? Look at the unit circle you just filled out, the blank sheet of paper for the warm-up. Yeah. Root 2 over 2. Remember, your sine is your y value. What's the cosine of 45? Root 2 over 2. Because that's the x. So, I have my two values for sine and cosine, y and x. Tangent is y over x. So, root 2 over 2, root 2 over 2. These 2's cancel. So, what is root 2 over 2, root 2 over 2? 1. Good. Tangent of 45 is 1. Okay? So I'm going to want you to try the rest with a partner. Okay? Use the unit circle you filled out at the beginning of class. Okay? I'm going to give you about 5 minutes, okay, to find the exact values of the rest. Okay? Work with a partner. Okay? Work with a partner to help each other out. So D through J. All right? All right. So, the sine of 150. Let's see. Rory, what do we have? 1/2. Good. Awesome. Cosine of 150. Yeah. Good. Negative root 3 over 2. Good. Okay. Tangent of 330. Mia. Good. Negative root 3 over 3. So far, any questions on those three? Are we okay? All right. The sine of 90. Tyler. 1. Good. Sine of 135. Finn. Good. Root 2 over 2. Good. Cosine of 270. Emily B. 0. Good. Tangent of 180. Right here. Chris. 0. Okay. Now, tangent of 180 is 0. Tangent of 360 is 0. What happens tangent of 90 and tangent of 270? What do we think? Tangent of 90 and tangent of 270. Yeah, Finn. Careful. Careful. 180 and 360 are 0 for tangent. What would happen, or what fraction do you get in terms of 90, tangent of 90, and tangent of 270? Yeah? Okay. Undefined. Good. So, tangent of 90 and 270 is undefined. Okay. Tangent of 90 and 270 is undefined because you have 1 over 0 and negative 1 over 0, which can't happen. Okay? So, this leads us to our next part, all right? We have been talking a lot about similar, okay, how things are similar, okay? We do have repeated answers in terms of sine of 30 and sine of 150 have the same value, okay? Due to they have the same reference angle, okay? That's where we are referring back to quadrant 1, okay? Hence the same colors. Same colors mean you could possibly have the same values, okay? So, the reference angle, okay, on the unit circle they have the matching colors, okay? Some key points to note, right, that a reference angle is only between 0 and 90. Okay, your reference angle only comes from the first quadrant. Okay, so for 300, our reference angle is 60. Okay, for 240, our reference angle is 60. Okay, it always reverts back to the first quadrant. Okay, and if we needed to, like we mentioned before, where the fourth quadrant was giving us some issues, you always want to look at the closest x-axis. Okay, the closest x-axis. Okay, so I gave you a few of these already, but we want to state three angles that have a 60-degree reference angle. Okay, so what's the first one in quadrant 2? 120. So if I ever needed to find that in quadrant 2, I would take 180 minus 60 to find out that it's 120. Okay. Anthony, please pay attention. Okay. In quadrant 2, or 3, sorry. In quadrant 3, what has a 60-degree reference angle? What has the same color in quadrant 3? Careful. Too much. Yeah. 240. So we would take 180 plus 60 to get 240. Okay. Then in quadrant 4, which we talked about earlier, what's the angle in quadrant 4? 300. So we would take 360 minus 60 to get 300. Okay. Now I want you to state three angles that have a 45-degree reference angle. Okay. Go ahead. State three angles that have a 45-degree reference angle. Quadrant 2, you're subtracting the reference angle given. Okay. In quadrant 3, you're adding. Quadrant 4, you're subtracting. Okay. So again, we're still using the x-axis. Okay. So, what's the first angle to have a 45-degree reference angle? Luce, what do we got? 135. Excellent. So 180 minus 45 gives us 135. Okay. What is the second quarter? Yep. Good. 225. Okay. In quadrant 4, Anthony. Okay. Tate. 315. Excellent. So 360 minus 45 gives us 315. Okay. So that's how you could tell what angles have reference angles. On the flip side, if you turn the page, we need to find the actual reference angles. Before we were given the reference angle, okay, now we have to find it, okay. First, we have to determine what quadrant it's in. So, for A, 182, what quadrant would that be in? 3. So, to find the reference angle, 182 minus 180, what do we get? 2. 2 degrees is the reference angle for 182. Yeah. Because it's in the third quadrant. Here in the third quadrant, we added because we knew what the reference angle is. So since it's in 182 is in the third quadrant, in order to work backwards to find the reference angle, you take the given angle and minus 180. Okay? Thanks, Dad. So 220, what quadrant is that in? 3. So we're going to do the same thing. 220 minus 180 is what? Nick? 40. Good. 315 we actually already found. What quadrant is 315 in? 4. So since it's in quadrant 4, what is the closest degree for the x-axis? 180 or 360? 360. So since it's in quadrant 4, 360 minus 315. And what do we get? 45. Good. Okay. 306 is in what quadrant? 4. So we're going to do the same thing. And what do we get? 54. Good. Okay. So here's another one, because we have seen a lot of 3 and 4. How about 100 degrees? What quadrant is that in? What quadrant is 100 in? Yeah. Good. It's in quadrant 2. So we take 180 minus the angle, which is 180 minus 100, which is 80 degrees. Okay, so add that somewhere on your notes so you have something to refer back to, especially with quadrant 2. I added 100. That's in quadrant 2. So you take 180 minus the angle to find the reference angle. Okay? Make sense? Are we okay? All right. And the last few things we are going to do today is given a point. Okay? Given a point. One thing to note, that you are always starting here where it's 0. You're always starting here. Okay? And the way the unit circle works, we end up going counterclockwise. If you notice, all the degrees got larger, okay, all the way around. So, first I want you to determine 8, negative 6 is in what quadrant? 1, 2, 3, or 4? Nick? 4. Why? Good. So this is in quadrant 4. Okay? So we're going to create a triangle. Okay? The angle is always going to be in the center. Okay? So we know it's in quadrant 4. Draw a line out, and then drop a perpendicular line. Okay, here is my angle, always from the center. Okay, so I know my point is 8, negative 6. Hypotenuse is always positive, right? So, but I have a point 8, negative 6. Can I label those side lengths at all of that triangle? Using that point? Camilla, what do you think? Perfect. Good. Okay. So here's our angle. 8 is our x value. It's our horizontal. And -6 is our vertical. So from this angle, this would be our opposite. This is our adjacent. What do I need to find? Hypotenuse. What do we use in order to find the hypotenuse? Go ahead, Finn. Pythagorean theorem. So let's see what we get for our hypotenuse. Okay. So we have 8 squared plus -6 squared plus c squared. Anybody have what c equals? Luce? 10. Good. C equals 10. Okay. Now, just so we can refer back to, we don't have to simplify right now. Okay? We're just going to keep it as is. So, my triangle is completely filled out. Is everyone okay? How do I find the sine of theta? What is it? Using the numbers given, don't reduce. What's the sine of theta? Go ahead, Mia. Good, -6/10. Opposite over hypotenuse. And the angle always comes from the center. Okay, so if you had to label, this is your opposite, adjacent, hypotenuse. What is the cosine? Finn? 8/10, good. What is the tangent? Go ahead, Nick. Yep, -6/8. Okay, everyone see that? All right, let's try one more. Yeah, Tate. For now, I want you guys to refer back to this, of how we got it. Well, you could reduce if you can make those connections, or put equals -3/5. You could do that as well. But I want you to be able to refer back to our triangle we created. Okay? So if we were given -2, -1, what quadrant is that in? Hannah? 3. Good. All right. All right. So here's how you draw your triangle in quadrant 3. And I'm going to show you how to draw it in 1 and 2 later. How do I label? What do I do using my point given? Hannah? Good. -2, -1. What do you have to find? Hypotenuse. Go ahead. Find the hypotenuse on your own, and then find sine, cosine, and tangent. Okay, go ahead. All right, what is my hypotenuse? Camilla? Careful. Go ahead. √5. Okay, so you have -2 squared, -1 squared equals c squared. Remember, when you're squaring a negative, it becomes positive. Take the square root. So c equals square root of 5. Okay? So now, when you're finding your ratios, remember, we have to make sure we rationalize the denominator. So, what is the sine of theta? Let's see, who haven't I heard from? Liam. Good. -√5 over 5. Excellent. Okay. Cosine of theta. Tyler. Give that one yet? How'd you set it up? Let's start that. Good. -2 over √5, right? Now we have to multiply top and bottom by root 5. Well, you have negative 2, right? Root 5 over 5. Okay, good. Tangent. Let's see. Ken, go ahead. 1/2, because it's negative 1 over negative 2, which is 1/2. Okay, so I drew you guys a diagram up above to show you what the angles look like. Okay, mine's a little off center, but in quadrant 1, it goes up and then down. Quadrant 2, up and down. Okay, 3 and 4 we did. So you might want to jot this down to show, because I've seen triangles coming in all different directions. Okay, but it's always from that central point, out and then down. Okay, making the bow tie like we referred to before. All right. So the last thing for today, we are given a trig ratio. Okay. Tangent of theta is 5/12, where sine is less than 0. So what does that mean, less than 0? Sine must be what? Yeah. Negative. So your sine must be negative. Okay. Find the exact values of the 2 remaining trig functions. Okay. My question to you is, where is tangent positive? What quadrants is tangent positive? Yeah. Quadrant 1, where else? If quadrant 3, okay? Out of those 2 quadrants, quadrant 1 and quadrant 3, where is sine negative? Quadrant 1? 3, okay? So we know we will be drawing our triangle in quadrant 3. Okay? In terms of SOHCAHTOA, tangent is opposite over adjacent, or y over x. So, how can I label this triangle? What's going to go where? How can I label this triangle? This? Left 12 and down 5. Good. So your horizontal is 12 and my vertical is 5. Do I have to also include something else? We have to find the hypotenuse, but before that, look that we're in quadrant 3. Go ahead. Negative. We should have negative 12 and negative 5. Because what's the deal in quadrant 3 in terms of x and y? They're both what? Negative. Therefore, that's why tangent is positive. Okay? So now we have the same setup as we did above. Find your hypotenuse. Yep. It's always positive. Hypotenuse is always positive. Great question. Hypotenuse is always positive no matter what. What did we get for our hypotenuse? Loose? 13. Good. Okay. So now that we have our hypotenuse, what is this sine? Good. Negative 5 over 13. What is our cosine? Go ahead, Em. Good. Excellent. Okay. Do you guys have any questions? Okay. Try the last one on your own. It's on the next page. Okay, I'll leave this up here. Try the last. What quadrant are we in? Leah? 2. Quadrant 2. Because cosine is negative in quadrant 2 and 3. However, where tangent is negative is quadrant 2. Okay? So we're in quadrant 2. Okay? And cosine is adjacent over hypotenuse. So this is -3, and this is 5. What is our missing side length? Four. It is 4. Okay. I'm going to stop right there. Any questions of right now? Is anyone stuck as to where to label, what to do? Yeah, Porter. Because this is adjacent, great question, over hypotenuse, right? So I know that 5 cannot be negative because it's the hypotenuse. So the -3 is going to stick with the -3. Okay? And then you do the Pythagorean theorem to find your missing side length. However, this time you're finding your side length. So we have 9 plus b squared equals 25. B squared equals 16. B equals 4. Now, it could have been plus or minus 4, right? Okay. So keep in mind that this could have been, let me take the square root, plus or minus. But since I'm in the second quadrant, I need my b value to be positive. Okay? So what is the sine of theta? Finn? 4/5. What is the tangent? Zach? Good. -4/3. Good. Excellent. Okay. We covered a lot today. Okay. We have covered a lot today. Your homework is going to be the 6.2 practice. You're going to skip 24. Okay, this is on, let me get the pages, 9 through 12. Okay, so 1 through 23. 25 might be a little bit of a challenge, but I want you to try it. And the unit circle. Fill out the unit circle completely. Okay? This is on pages 9 through 12. Okay? And it's spaced out. The first part is exact values. 13 through 15 is identifying what angle it is given the coordinate point. Okay? Let me get started on that now.